As we continue our unit on extending to 3 dimensions, we're going to get into talking about surface area, and specifically surface area of prisms and cylinders. I talked to you about what makes a polyhedron a prism, and about cylinders and how they're not polyhedron. And so we'll talk about that today and talk about how we can find the surface area. So remember, as we talked about prisms, that's a shape that has the same base all the way throughout, the same shape all the way throughout. Every part of the cross section is the same as we take parallel cross sections. So we've got a rectangular all the way through here. And a cylinder is similar, except it's not a polyhedron. So we've got a circle cross section all the way through. So as we start to talk about surface area, I'm sure you've learned about surface area before and thinking of it in terms of a net, or think of it as like a pizza box if we think of a rectangular prism. So the surface area is the area of all parts of the box that fold up to make that shape, or we can refer to it as a net, which is a two-dimensional representation of the solid. So if we take that three-dimensional figure, so let's say we've got our rectangular prism. If we unfold all the pieces and make a net, we're trying to find the area of each of those faces, is another way to think of surface area. So we can think of surface area, as I mentioned, by finding the area of all the faces. We can take the lateral faces and find the sum of all those, along with the bases. We know there's going to be two bases in a prism because it maintains that same cross section all the way through, and then the lateral faces are going to be a little bit different because you might have a couple that are the same, a couple that are not the same. So if we take a look at the formula for the surface area of a prism, we say the surface area is the sum of twice the base area and the product of the base perimeter times the height. Because if we take that whole surface area, and basically what we're doing is we're taking the area of the base, the front and the back, so we have two of those, and then also if we take the perimeter of that and we were to unfold all those sides, so take the perimeter times this height, because that'll be the unfolded area as we see here. So another way to do that would be just to find the area of each of the faces and to find the net. So you can do it whatever way is most convenient for you. So why don't you try this example that we have on the triangular prism, and when you're ready you can take a look at the solution. I'll show the net and I'll also show you the applying the formula as well. So restart it when you're ready to see both methods. Okay, so when we take a look at this triangular prism, I'll show you the nets first. I just broke it into the different faces and showed you the area of each of the faces. I find that's easier for myself. So I have the front 6 times 8 and the back 6 times 8 divided by 2 is each 24. And for this face, it's 10 by 18, which is 180. The bottom face, 8 by 18, which is 144. And this side face, which is 6 by 18, which is 108. Add them all up, I get 480. Applying the formula, 2 times the area of the base. Well, the base is this triangle, so 6 times 8 divided by 2. So keeping in mind when you take the surface area of the prism, you got to apply the formula for the area of the base. Plus the perimeter of that base, 6, 8, and 10, times the height between the two bases. Simplify it, I get 480. So I would suggest just pick and choose whatever is easiest for you and then work through it. If it makes more sense to write out the nets, go ahead and do that. Then just keep in mind as we look at the nets for the cylinder, know that we've got that same base shape on top and bottom. And then when we unroll it, I like to think of the soup can. If you take the label off the soup can, you got a rectangle. So you've got the lid on the top and the bottom, and then the soup label. So you've really got a rectangle and two circles. And as we take a look at the two circles, we know the area of a circle is pi r squared. So we've got 2 pi r squareds. And then the soup label part, we've got the height of the label, and then the distance around the label would be the circumference, same as circumference, which is pi times 2r, 2 times pi times radius. So this area is 2 pi r times h. So this plus 2 pi r squareds gives us the surface area of the cylinder, and that's how we come up with that formula. So as we take a look at that area formula, we've got the lateral area, which is the soup label, and then we've got two base areas, which are top and bottom of the can, which is how we come up with that area, or the formula for the surface area of a cylinder. 2 times the area of the base plus the circumference times height. So we have 2 pi r squareds and 2 pi r h. We add those up. So that's how that makes sense. If you ever forget the formula, just think of the two top and bottom lids and then the soup label. Draw it out if you need to. Okay, so this time we got a racquetball container. We want to find the surface area of the whole container. So find the area of the label along with the two lids. So I've got an example on the bottom with the nets. So maybe do the nets example and then try to use the surface area formula on the top one. So 2 pi r squared, the two circles, plus 2 pi r h, the soup label. And plug those in and restart the video when you're ready to see the solutions. Okay, so as we take a look at the racquetball surface area, we've got 2 pi r squared. Radius is 1.25 inches, since it's half the diameter, plus 2 pi r h, height being 5. We simplify that down, and I get 15.625 pi inches squared. That's exact value, or approximately 49.09 inches squared. And then if we take a look at the net below, I know this circle, pi r squared, so 12 squared times pi, same for both of them. And then this height is 10 times its circumference, 2 pi r. So I have 24 pi, since my radius is 12, so 2 times 12 is 24 pi, so 10 times 24 pi is 240 pi for this rectangle. Add the 3 up, I get 528 pi, or approximately 1,658.8 units squared. So we took a look today at finding surface area. We found surface area of a cylinder and surface area of a prism. Just keep in mind that whether it's a prism or a cylinder, they have this identical bases, so find the area of both of those bases, plus the lateral area, which is the perimeter of that base times the height. So feel free to make a net if you need to. Otherwise, you can follow the formulas.